In this example, we are going to go over agglomerative clustering technique, but the data is going to be categorical data. And start a new job, and she's going through the file that contains a list of students in an academic department and would like to gain a better understanding about the study body in the department. All the variables are categorical with value 1, implying that the given student is a transfer student, was on the dean's list last semester, and is currently receiving financial aid, or is female, respectively. So we have two jobs or two tasks to do. Perform agglomerative clustering to group the students in AGNES data set using matching coefficients. So matching coefficients, either we use Jacquard's or matching. For the similarity measure and the complete linkage clustering method, inspect the dendrogram and how many clusters are generated if the minimum distance between clusters is 0.8. How many transfer students are in the largest cluster? Repeat the part A, but we're going to use average linkage clustering technique. Again, we're going to look at the dendrogram, how many clusters are generated if the minimum distance between clusters is 0.45. How many transfer students are on the dean's list in the largest cluster? So first, let's get the data. Again, with the library is a cluster. Exploring the data just to make sure that all of them are really categorical. I mean binary. At least if we can see that from here, we have 0 1s already. And it says numeric, but actually they are 0 1s. There is no need to change them, by the way. After that, let's find the distance. So the distance D is going to be, now because we are going to use distances that we know, like Manhattan, Euclidean, or Jacquard's. So we can use the distance function, and we use this in chapter 11, I guess. So the distance for my data, and there is nothing to be excluded, all of the variables are there. So the method is going to be binary. So we have two arguments here. This is the distance among the observations. After that, we are going to perform agglomerative clustering technique results, AGNES. Then we're going to have the distance. Then we can say the method is, what does it say? Complete? Complete, I guess. Let's add one more argument, which is the dissimilarity measure. We have to have it true all the time. And we can look at the results if you would like. The coefficient is 1. Let's plot that one. So plot the results, dendrogram, which plot is 2. And we can just look at that one. If you'd like to make this one smaller, you can make it smaller. But let's focus on so the question says 0.8. So how many clusters? At least the distance is 0.8. So we need to, let's create a line, AB line. AB line horizontal equals 0.8. So I'm going to create a horizontal line. Let me make a color red. So now I have the 1, 2, 3, 4, 5. I have 5 clusters. 5 clusters. So to do the next, so we're gonna create a cluster. So clusters. Cut tree results. How many Ks? 5. How many clusters? 5. So now we have 5 clusters. So the question says now, let's look at the clusters. Let's look at how many observations in each cluster. So to do this, let me get the table clusters. Oh, but let's do something before. Let me add the clusters because we have already 5. So clusters. We have 5 clusters, but let's do the following. Let's add this to my data. Let me call it big C clusters. So I'm going to add this to my data just for, so every observation contains the cluster, or it's assigned to the cluster that it belongs to. Now we can create a table of my data clusters, so we count them. So the largest cluster is 3, right? 3. So now let's subset the ones who are, how many transfer students are in the largest cluster. So we need to go to the largest cluster, which is the 3rd cluster, right? And we need to count how many ones are transfer students. How many are transfer students? You can use many, there are many ways can be done. We can use the subset. Let's subset it. My data transfer. Also, subset based on the cluster equals 4. Let's find the summary of this. Clusters C. We have zeros. Yeah, maybe because my data transfer is a numeric, so let's change it to categorical, so as factor. Here we go. So you have the summary of the factors now. We have zeros, ones. Clusters equals 4. We're looking for 3, not 4, by the way. Clusters 3. So how many total observations in that cluster is 33? We subset that one. We just want to look at the transfer. So how many transfer students do we have? We have 12. How many non-transfer students do we have in this cluster? Is 21 students. So this is for the first part. The second part is repeat, choose average linkage clustering method, inspect dendrogram, how many clusters. So we're going to repeat this, but we're going to change from complete to average. Then we're going to look at the AB line from 0.8 to 45%. Then how many transfer students are on the dean's list? So we're going to change it from from the transfer to the dean's list. So I'm not going to do this. I'm going to leave this to you to complete. So just imitate this exactly. And you're going to change a few numbers here and a few variables here and there. So this is using agglomerative clustering technique when all of the data is categorical. And if you just notice, the only difference that we had is the function distance. In the other one, we use the goer distance. Now, the mixed data. For this one, we just use the distance function.